Let's go ahead and look at number 3. That's all right. Let's see. What did I say? 9? Yeah. Okay, too much flipping. All right, so we've got an angular velocity for flywheel obeys the equations. Now, I'm not going to draw it. This is on page... I'm going to draw it, but I'm not going to put the teeth on the flywheel. Is that all right? It's a flywheel. Just write flywheel. Okay. All right. So it obeys this equation. Now, you know good and stinking well when you get an equation what it's going to probably end up leading to. A plus BT squared. So A plus BT squared. Okay. Where T's in seconds and A and B are constants having numerical values of 2.75. So A has 2.75 and B is 1.5. All right. Okay. What are the units for A and B in radians per second? Okay. All right. Now, first of all, let's kind of regress here and remember we're looking at angular velocity. That's angular velocity, right? Omega, angular velocity. Now, we've got a function or an equation, so we need to remember that the angular velocity is equal to what? D theta in radians, and that's in radians now, over what? dt, isn't it? In other words, it's the derivative of the angle in radians with respect to time, right? Okay. Okay, so the first thing we need to do is assign units, okay? All right, if I were to take the derivative of that equation, what would it end up looking like? And the derivative of that, by the way, is what? It's angular acceleration, isn't it? Yeah. So if I take the derivative, then it becomes angular acceleration, and the equation becomes what? 2bt? Right? I didn't write as the limit approaches 0. You know that. Okay, you know it's got limits. It's a derivative. All right? Okay. All right, so what would my units need to be in? So let's think about this. If I want to get omega in my answer, if I were just to give you values, not take a derivative, just give you values and say, okay, what is the angular, see if I said what is the angular velocity, you wouldn't have to take the derivative, would you? Because you've already got it. That's the function or the equation for the angular velocity. So if I said, okay, what's the angular velocity at 3 seconds? You just plug in 3, plug the values in, boom, you'd have angular velocity. So how would I get angular velocity from that? Well, this one should be what? Radians per second, right? Because what is angular velocity? Radians per second, right? And then this one would have to be what? Well, how do I cancel it out and get radians per second in my answer? Well, it has to be radians per what? Second cubed, don't it? Right? Because seconds squared is second squared, and so that cancels it out and leaves behind a what? A second, doesn't it? And then we have the answer in radians per second. So it's dimensionally correct. Correct? Everybody follow what I'm doing? If I were just to give you the time, plug it in, that's what the unit should be. So that right there is part A. There's A right there. So you got to think, oh yeah, how do I get radians per second? What is angular velocity? Okay, that's how we do it. All right, any questions on that? What is the angular acceleration of the wheel at time 0 and at time 5 seconds? Okay, well we got to do what? What is the angular acceleration? The angular acceleration is d omega over what? dt, isn't it? So what is omega? What is omega? It's that function, isn't it? That equation. So take the derivative. We've already done that, y'all. We've already done that. Okay? All right. It's a lot easier to do derivatives, isn't it? Let's just do a derivative. Yeah. It's a whole lot easier. So we got 2 times what? 1.5. And that's what? Radians per seconds cubed times what? Now, do I need to do 0 seconds? Come on, y'all. What's it going to be at 0? 0. Do I need to do that? Yeah, go ahead and do it. Okay, keep y'all happy. And that's what? So look, cancel. Cancel, that becomes 2. Then the answer would be what? 0 radians per second squared. And then that's at time 0. Excuse me. At time what seconds? 5? Yeah, 5. 2 times 1.5 radians per second cubed times 5 seconds. And we get what, 15 radians per second squared. Is that right? Okay, good. That's easy, isn't it? Yeah, put a bunch of those on the exam, right? Yeah, one. Maybe. I can't put them all, y'all. It's hard for me to make this test out because, you know, I have to try to give you kind of a balanced diet of what you've had. We've done a lot. And there's a lot in each chapter, so it kind of makes it hard. Okay? What I think is most important and you'll need to remember the most, you know, be the most important thing you need to remember. But anyway, we'll do it and go on, and you'll be fine. All right, now let's do 3C. That was 3B, wasn't it? 3B? 3C. All right, now 3C makes us think a little bit. All right, through what angle does the flywheel turn during the first 2 seconds? Okay. All right, now, we've got see, we were not given angular velocity, were we? We were given an equation. All right, we know that angular velocity is what? It's the derivative of the arc in radians with respect to time, okay? So we want to find the what? The arc in a given time interval. So let's rewrite our equation. D theta over what? Is equal to what? Omega dt. And let's integrate it, and it becomes what? It becomes the change in theta is equal to what? The integral of 2 to 0 omega, shoot, I can't even think. Yeah, I'm writing it right. Omega dt, right? So let's integrate it. I'm running out of room. Dadgummit. All right, so now let's actually do the integration. All right, so we got what? So it's 3C. So we got the change in theta, or theta, final theta, if you want to write it that way, because initial theta was 0. It doesn't matter how you write it. Change in theta or final theta is equal to the, let's integrate it, and that's omega, and that becomes what? But now wait a minute, what is omega? Uh-oh, I forgot that. What is omega? What is omega? What the heck? Really, dude? That was what? A plus B t squared. That was weird. All right, now. So let's do that then. A, well, t plus B t cubed over 3. Well, I'm going ahead and doing the integration. I left a step out. I'm sorry. Do I need to go back and put a step in? Here we go. A plus B t squared dt. Now let's keep everybody happy. There we go. Now let's integrate it. Now you're right. I should have showed you that. I left a step out. Okay? All right, now that's easy. All right, so let's do it. So we got theta is equal to what? Well, it's 2 to 0. And so this is 1.5 radians per second, right? Yeah. Times 2 seconds plus, did I write them backwards? A was 2.75. Yes, dang it. Sorry. That was 2.75. And this is 1.5 radians per second cubed times what? 2 seconds cubed over 3. You could reduce that and just say 1 over 1.5 times, yeah, you could, but I'm not going to. And so theta then is what? Final theta, or the change in the arc in a 2 second time interval, is what? 9.5 radians. Because look, what is it over here? It's minus 0. So I don't need to do the second part because it's 0. And so it's 9.5 radians. Everybody get that? This part right here when you do the calculation is 5.5 radians. And this part right here when you do the calculation is 4 radians. And don't forget, you don't put your calculator in radian mode because we're not doing sine and cosine. Okay? Don't forget that. Next semester we will. A little bit. All right, you with me? That was easy, wasn't it? Easy integration. But you had to think about you had to remember, oh yeah, this is a derivative, and since I have an equation, I've got to do what? Well, to find the angle, I integrate it. I integrate the angular velocity with respect to time. Okay? All right. Good problem. Okay, that's about time for today. And